Okay, class, we're going to continue our discussion of ecology, ecosystems, and the environment. And this time we're going to focus on challenges. Challenges to the environment, which are challenges to all of us. Now, earlier we talked about climate change, global warming, the production of carbon dioxide and the correlation between the carbon dioxide levels in the atmosphere and the global annual temperature. And although we focus on increases in the global annual temperature, there are also, in general, climate changes associated with that, including changes in weather pattern, rainfall, and some of the other things that we're going to talk about. So in general, we're going to talk about the anthropogenic impact on the environment of we humans. On the left side of this slide, I show some of the results. Carbon dioxide production and global warming, climate change, again, which we've talked about a great deal. Also, acid rain and the acidification of the oceans, which we briefly mentioned, which is a type of climate change related to carbon dioxide production. In this video lesson, we'll talk a little bit about ozone depletion. We could also, if we had time, talk about natural resource depletion and reduction in the biodiversity, pollution of the air, land, and water, loss and contamination of groundwater and freshwater reservoirs, and in general, the loss of arable land which we can use for farming. After many decades in which there was an increase in the amount of arable land, largely due to deforestation, which is on the right column, in recent years there's been a decline each year of the amount of arable land due to erosion and soil degradation. Now, the left side is more or less the results, but the right side is some of the driving forces. What is causing this? And probably the biggest driver is the increase in global population over time. Around the year 1800, there was between 1 to 1.5 billion people living on this planet Earth. Now we're between 7 to 8 billion people sharing this planet. There are more people living in China now than lived in the entire Earth around 1800. And everyone aspires to an affluent lifestyle, have automobiles, air conditioning, refrigeration, the internet, etc. One of the causes of the problems is deforestation, that is, cutting down trees to clear land, pave paradise, and put up a parking lot. That was a song back when I was young. The Industrial Revolution of the 1800s completely changed the way that we manufacture, but as a result, it required us to use a lot more energy. Increased use of fossil fuels for heating, cooling, industry, cars, etc. Changes in agricultural practices, use of fertilizer and irrigation, for example. Livestock production practices and overfishing. These are a lot of topics that we could talk about, but we're only going to hit a few in this video lesson. At the bottom right, I show an equation. Now, this isn't a real scientific equation, but it's one that is oftentimes used in the discussions of the environment and challenges to the environment. And it is I equals PAT. I being the human impact on the environment, that being equal to the product of P times A times T, where P refers to the population. The more people you have, the greater the impact. A being an affluence factor, which can be described as the amount consumed by an individual in this population, and T being the cost of a particular product. Now, let me give you an example. Let's say the production and consumption of beer, for example. And what is the environmental impact on the production and consumption of beer? Well, it would depend upon the population of beer drinkers, right? That would be the P, the population. The affluence would be the amount that they consume of this product per individual, and T would be the cost in natural resources to produce that beer, that can of beer, which would be made out of aluminum, and the grain used to make the beer. So in general, this equation says that the impact of any product or any practice that you can think of will depend upon the population of people participating or requiring this product, the amount that they consume of this product per individual, and the cost to produce this product. Now, we've talked about global warming and climate change, and quickly I'm just going to highlight One aspect of this, maybe you like warm weather, but a consequence is going to be that the melting of polar ice caps will contribute to a rising of the sea levels, flooding in low coastal areas, and this will cause people to migrate inland. So as you can see from the maps, if you happen to own some property in the Mississippi coast or New Orleans and Louisiana coast, you probably want to sell it pretty quickly. Go ahead and buy some lakefront property on like the Great Lakes. Also, we talked about the consequence of global warming on crop production and so forth. Another topic I want to talk about, another challenge, is ozone depletion. You may or may not have heard of ozone. Ozone itself is a small molecule. It's actually oxygen. It's what we call an allotrope of oxygen. It is O3 instead of O2, which is the predominant form of oxygen here on planet Earth. Ozone exists in our upper atmosphere, and it actually has both good and bad properties. It can be an irritant to us, but if it's in the upper troposphere, it actually has a useful function. It absorbs ultraviolet light, and in doing so, it protects us because it prevents the ultraviolet light to shining through and striking the Earth, and of course, ultraviolet light can cause skin cancer. Back around 1980, some scientists discovered something that was very concerning, and that is they discovered what is called a hole in the ozone layer. Shown in this slide is a picture of our planet Earth, the globe, from viewing the South Pole. And the blue area is this hole in the ozone layer that was discovered. And you can see it was as large as a continent, or larger than the continent of Antarctica, meaning that ultraviolet light was able to shine through and strike the planet. Well, of course, there aren't too many people living in Antarctica that we had to worry about skin cancer or the effect on plants. But the concern was that this would spread, and it was spreading until we took some actions. And that's because scientists discovered what was causing the depletion of the ozone layer. It was actually another group of chemicals called chlorofluorocarbons, CFCs. That's a big word, and I know, let's just call them CFCs, which are chemicals, or fairly inert chemicals, and they were used as refrigerants and also used in various sprays like hairspray and deodorant. And when it was realized that CFCs were reacting with ozone in the upper atmosphere, the troposphere, and breaking down and destroying the ozone, when that was discovered, then there was a big move to replace the propellant, the gas propellant in spray cans from CFCs to carbon dioxide or other compressed gases. And due to that action, there has been a stabilization, and actually the ozone layer is replenishing. That has been one success story about how we have understood the human impact on the environment and have taken corrective actions. Another topic is acid rain. Now, as we burn fossil fuels in our internal combustion engines and in coal-powered electrical plants, we produce gases. We talked about carbon dioxide, but also we release nitrogen oxide, nitrogen dioxide, sulfur dioxide, other gases. Well, some of these gases, in particular nitrogen dioxide and sulfur dioxide and trioxide, can combine with water in the atmosphere to form nitric acid and sulfuric acid, which you don't need to know a lot of chemistry to know that when you hear nitric acid and sulfuric acid, it sounds like that's a little bit of a problem. And these acids combine with water droplets to produce acid rain. Now the problem is that has an impact on plants. It doesn't harm us so much yet, but it stunts the growth of plants, causes their premature death, alters the fertility of soil, and so forth and so on, and also harms the fungi that live in the roots of the plant. And this is shown an example of a forest that has been harmed by acid rain. Another challenge to our environment is urban air pollution. Again, as we burn fossil fuels in our power plants and in our heating our homes and in our internal combustion engines, we produce these oxides of other elements, including carbon monoxide, nitrogen oxide, nitrogen dioxide, sulfur dioxide, etc. These gases can combine with particulate matter to form what we think of as smog. And also there can be chemical reactions, which we won't go into, that can lead to the formation of ozone down at the layer of the surface layer of the atmosphere, which is where we would breathe the ozone, which can have harmful effects to us. In particular, those people who have asthma, ozone and these other gases can be severe irritants. COPD, lung cancer, can cause premature births, etc. And that is one of the reasons why for a number of years we have put catalytic converters in cars. Why? Because the catalytic converters trap the nitrogen oxide, sulfur dioxide, or actually cause them to break down before they can be released to the atmosphere. Also, the power plants have scrubbers, and we've also have this movement to try to use this, to the extent possible, clean energy sources so as not to release these gases, these noxious gases, into the atmosphere. The bottom shows a picture. This happens to be in a city in China, in case you're trying to read the billboard, on a clear day and then a day where they have severe smog. Okay, so we've talked about some of the challenges, but let's also talk about, let's be positive and talk about some of the services provided to us by the ecosystem or by the environment. What are some of these benefits that we gain, oftentimes, or maybe in all cases, free of charge, that the environment gives to us if it's all working properly? What I'm talking about is such things as the purification of water through our ecosystems, the purification of the air, the recycling of nutrients for recreation. That's a benefit provided by the environment. The food that is produced, the oxygen that is produced in photosynthesis, flood and drought prevention, materials that we then use, wood, for construction. So there are a number of services that are provided to us by a properly functioning ecosystem. We got to appreciate that. So how much is this ecosystem worth to you personally? So we're going to end this with an assignment. I want you to look back at the previous slide, pick an ecosystem service, do a little bit of research on this service, and answer the following questions. Which of the ecosystems that we've talked about, or the biomes that we have talked about, are noted for this type of service to you? Describe the value to you personally of this service, and what are some of the threats to this service that is provided to you? What actions can be taken to prevent these services from being threatened further by either you or others? And in general, in what ways are you eco-friendly? I want you to prepare a one-page report supported by at least one web source, and we will just have this for discussion in class. And I want to leave by just showing you this little link to a video in case you just happen to have some time and want to watch it's kind of funny, a little video created by these four guys about ecology. So that's the end of our chapter on ecology, the environment, and ecosystems. Hug a tree. And if you don't feel like hugging a tree, because I understand some of you may not be that touchy-feely, plant a tree. See you later.